Hello, in this lesson we are going to be going over similar polygons. So what does similarity mean? Well, I put up one of my favorite photos from the Camino de Santiago in Spain this summer, and one of the photos is smaller than the other. In fact, there are three photos up there, and in two of the photos I look like myself. In one of the photos I look a lot thinner, which would be lovely, but that looks less like me. You know there's something wrong. So similarity means that you retain the same shape even if it's a different size. So my shape and the shape of my face here is still the same. The angles on the mountains, the slopes there are actually the same slopes. Here you can see this mountain is a lot steeper. So now let's bring it into geometry. I've got two similar polygons here, and what can we find out by looking at these two similar polygons? First of all, let's look at the angles. This angle is 53 degrees on the lower left, as is that angle, the green angles. The two blue angles are both 127 degrees, the corresponding angles there. And then the other two corresponding angles are 90 degrees. So if you look at it, are those angles proportional? Absolutely. In fact, they are all the way to congruent. They are exactly the same. Now, if I take a look at the sides, the red sides are not the same size. One is 5 and one is 25. The green side is 3 and the other green side is 15. So let's find out what we can see about those ratios. So I'm going to make a ratio, and I'm going to just, for this instance, I'm going to put the smaller one, the first one over the second one. 5 over 25 is 1/5. The green, 3 over 15 is 1/5. 4 over 20 is 1:5. And 6 over 30 is also 1:5. So the ratios of all the corresponding sides are equal. If you go to your notes, on the beginning it says two polygons are similar if their vertices can be matched so that corresponding angles are congruent and the lengths of the corresponding sides are proportional. Now, taking a look at your notes here, I went ahead and color-coded the two polygons. Polygon ABCD is similar to WXYZ. Now, why don't you take a minute and see if you can figure out which angles go with A, B, C, and D. Hopefully, and it wasn't that hard, you got W, X, Y, and Z. And that's because, again, the angles are congruent. Now let's look at the other piece, that the sides are proportional. If that is true, I should be able to set up a proportion with corresponding sides. So just to help you out, I kept my color coding here. And if I have side AD and AB, BC, and DC, what are the other parts to this proportion? Hopefully you got those, WZ, WX, XY, YZ. Now, if you said ZW, remember in a segment it doesn't really matter too much. If it was array, it'd be a bigger deal. But segments, the letter order doesn't really affect it. So the converse, if we switch things around, before we said if the polygons are similar, then the angles are congruent. So now we're saying if the angles are congruent and the ratios of the corresponding sides are equivalent, that means they're proportional, then the polygons are similar. So I can go backwards from angles and sides to show that polygons are similar. Just very quickly looking here at this example, this one's a little tricky, so be careful. I'm going to go ahead and do transformed over the original. So I'll say 40 over 35. You can see those are the two longest sides and they go together. Those are both divisible by 5 and that gives me 8 over 7. This one right here goes with a 24. So I'm going to say 24 over 21. Those are both divisible by 3 and that gives me 8 over 7. 32 goes with the 35, so I'm sorry, 32 goes with the 28. 32 over 28, those are both divisible by 4, and that gives me 8 over 7. So the ratio of all sets of those corresponding sides is 8 to 7. If I do these two rectangles here, they sure look similar, but are they? So I'll go again, bigger side to smaller side, 54 over 36. You can use your calculator to simplify. I happen to know those are both divisible by 18. Probably easier to do 9 first, so 6 over 4, which is 3 over 2. 24 over 18, both of those are divisible by 6, and that would be 4 over 3. 4 over 3 and 3 over 2 are not the same ratio, so these two are not similar. Now, another term you can learn about is the similarity ratio. We won't spend a huge amount of time on it, but that doesn't mean it won't show up on a quiz. Hint, hint. So, a similarity ratio is the ratio of the lengths of the corresponding sides of two similar polygons. And it's really easy to do. Basically, you just take the corresponding side of the very first polygon mentioned, in this case a triangle, to the second one. And the first one here is 3. Excuse me. And the second one has a side of 6, which simplifies to 1 to 2. Then you can also write a similarity ratio the other way, DEF to ABC, so now I'll have 6 to 3, or 2 to 1, if you simplify it. Remember, in ratios, order absolutely matters, and that's why it's important to label and use color when possible. The scale factor is something you will see a lot of, not only because it's used for the similar polygons in this area, but it's also used for dilations of same idea in the coordinate plane. So the scale factor is a multiplier used on each dimension that will transform the original figure into a similar figure. We find it very much like the way we find the similarity ratio. The important thing is that the transformed figure goes on top of the ratio and the original figure goes on bottom.